Hello students, this is Ms. Dalton and today's video is on solving logs and exponential equations with real-world examples. So let's first look at solving exponential equations. Now these exponential equations are going to be when we don't have the same base. So you're unable to get the same base on both sides like we were showing you in previous videos where you can change them to have the same base. So this is when they don't have that. The very first step that you're going to do is you're going to isolate the base with the exponent. Then what you're going to do is once you have that exponent by itself, you're going to log base both sides using the base of the exponent. And then you're going to solve for x. So let's look at this first problem. So in this first problem, we have 10 equals 5e to the 4x. So notice that the base with the exponent is the e to the 4x. So we need to get rid of the 5 first. To do that, we're going to divide both sides by 5. And then we're going to have 2 equals e to the 4x. Okay, I'm going to rewrite that up here so that I have a little bit more room. Okay, so now what we want to do is we want to log both sides with the same base. That's going to get our base to cancel. Now notice that our base is e, so the log that has a base of e is ln. So we're going to take the ln of both sides. What that's going to do is that's going to now cross off this part, and so we have ln of 2 equals 4x. Then we want to solve for x. So to solve for x, I would have to divide by 4. So what we would have now, I'm going to turn this around. We have x equals the natural log of 2 divided by 4. Okay, let's see what that looks like on the calculator. As you enter this in on your calculator, you can either enter it in as a fraction or you can just type it in as ln2 divided by 4. The ln button is right there by the 4 button, so you hit ln2, make sure you close your parentheses, and then do divided by 4. So it equals 0.173. So now what we're going to do is we're going to write that answer down. Let's go ahead and round it to the nearest thousandth. When you do your assignment, it will have how they want you to round it. So we're going to say that x is equal to 0.173. Okay, let's move on to the second example. So we have 5 to the x minus 4 equals 7. So again, we need to isolate that base with the exponent, and so we're going to add 4 to both sides. It's going to give you 5 to the x equals 11. And now we need to take the log base of both sides. We're going to use the base 5, so we need to do log base 5 on both sides. That's going to cancel this base and that log, so then x is going to equal that log base 5 of 11. Okay, so let's see how to do this on the calculator. Okay, to do this in your calculator, you're going to go to Alpha, Window, and then at number 5, you can see where it says log base. You're going to go to number 5, hit enter, and now you can enter the base as 5, and then scroll over and hit 11, and then hit enter. All right, so it shows that the answer for x now is 1.489, but then if we're rounding it to the nearest thousandth, that's going to be in the 9 position, which means you're going to have to look 1 past it, and because that's an 8 makes it round up, so it's actually going to be 1.490. All right, moving on to the next problem, we have 6 to the 3x minus 9 minus 10 equals negative 3. So the first thing you want to do is you want to isolate the base with the exponent. So we're going to add 10 to both sides. That's going to give you 6 to the 3x minus 9 equals 7. Okay, so now we need to log base both sides. My base is 6, so I'm going to do log base 6 on both sides. That's going to cancel again here because a log and an exponent are inverses of each other. It's going to bring that exponent to the front now, and so that's 3x minus 9 equals log base 6 of 7. So let's go ahead and do that on your calculator using those same tips. So to do log base 6 of 7, you want to hit alpha window and then go to number 5 and enter your 6 as your base and then 7 and then hit enter. So rounded to the nearest thousandth, that comes out to be 1.086. Now we're going to solve for x. So we need to add 9 to both sides. That's going to give you 3x equals 10.086. And then you would divide by 3. So x is going to equal 3.362. Again, I would recommend leaving the answers in the calculator and not rounding until the very end so that you get an accurate answer. Okay, now let's move on to solving logarithmic equations. The very first step for solving logs is you're going to move the logs together to the same side of the equation. Then you're going to condense the logs if you can or if needed. Once you have a single log, then now you're going to exponentiate both sides using the same base as the log. Then you're going to solve for x. And one thing that you have to do is when you're solving logs is you need to check for extraneous solutions. Remember that you cannot take the log of a negative number. So if you get a log inside, a negative number inside the log, then that's going to be an extraneous solution. All right, so let's look at this first example. We're going to need to get the log by itself. So we're going to subtract 7 on both sides. That's going to give you log base 3 of 5x minus 4 equals 3. Okay, now since we have a single log, we don't need to condense it because it's already a single log. So what we're going to do is we're going to exponentiate both sides. We're going to take the base of that log and now we're going to put that log up to the exponent. So now we've got 3 to the log base 3 of 5x minus 4. We're going to do that on both sides. So we're going to put the base of 3 on the right side as well. What happens with that, because exponents and logs are inverses of each other, these are going to cancel. So you're just going to have 5x minus 4 equals, that's going to be 3 to the third power, and 3 to the third power is equal to 27. So we're going to set it equal to 27. Now all we have to do is solve for x. So we're going to add 4 to both sides. That gives you 5x equals 31. And then we divide by 5. So x is going to equal 6.2. Okay, now you will need to check for extraneous solutions, but you really only need to put it into the log. So you just want to make sure that that's not equal to a negative number. So if I do 5 times 6.2 minus 4, we need to make sure that that is greater than 0. So 5 times 6.2 is 31, and 31 minus 4 is in fact greater than 0. So we're good. Okay, moving on to the next example. First thing, we want to make sure that the logs are together on the same side of the equation, and they are. But because I have two logs, I need to condense it. Well, anytime you have a plus sign in between two logs, it's going to condense to be the product. So we're going to have log of x times x plus 9 equals 1. So now that we have a single log, then now we're going to exponentiate both sides. Now this log, you can't see the base, but remember anytime it is not there, remember it's an understood base of 10. So we need to exponentiate both sides by putting the base of 10. So we're going to do 10 to the power of that on the left, and then 10 to the first power on the right. When you do that, the 10 and the log base 10 cancels. So we just have x times x plus 9. Now I'm going to go ahead and distribute that. So that's going to be x squared plus 9x equals 10 to the first power is equal to 10. Now, since this is a quadratic, we know that we need to get everything on the same side. So I'm going to have to subtract 10 over to the left side. So I'm going to have x squared plus 9x minus 10 equals 0. And let's go ahead and try and factor that. I do believe it does factor. It's going to factor as x plus 10 times x minus 1 equals 0. If I set both of these equal to 0 and solve it, then x could be equal to negative 10, or x can be equal to 1. Now let's go ahead and check that by plugging them in to see if any one of them is an extraneous solution. Well, when you have the log of x, and if I substitute a negative 10, that's going to be the log of a negative number. And we can't do that. Okay, so this is going to be an extraneous solution. But if we do 1, we'll have log of 1 plus log of 1 plus 9, which is 10. And so both of those check as being greater than 0. So x equals 1 is going to be your solution. All right, let's look at a couple of more examples. We're going to have log base 6 of x minus 5 equals 2 minus log base 6 of x. And then we're going to look at the example, the natural log of 8x equals natural log of 2 plus 5. So I'm going to move that second one out of the way real quick so that I have a little bit more room. Let's move this over. All right, so let's go ahead and get to work on this first one. So on this first one, you need to get your logs on the same side of the equation. So let's go ahead and move this one by adding it to the other side. So that's going to give you log base 6 of x minus 5 plus log base 6 of x equals, now since I added that over, then it's just equal to 2. Since I have two logs, we need to condense it, and so if you'll remember that condensing with a plus condenses down to multiplication. So we're going to have log base 6 of x minus 5 times x equals 2. So now, since we have that single log, we can go ahead and exponentiate both sides. My base is 6, so I'm going to do 6 to the log equals 6 squared. 6 to the log, that cancels. Now I'm going to go ahead and distribute that. So that's going to be x squared minus 5x equals, then we're going to do 6 to the second power. Well, that's going to equal 36. Then we need to move everything to the same side, so we're going to subtract that 36 over. X squared minus 5x minus 36 equals 0. And luckily this does factor. This factors as x minus 9 times x plus 4 equals 0. Again, to solve that, we need to set both of those equal to 0. So we're going to get x equals positive 9 and x equals negative 4. But again, we do need to check our answers to make sure we don't have any negatives. And if I plug in, so if I have log base 6 of x minus 5, well, when I plug in 9 minus 5, that checks because that does equal a positive 4, so that one's okay. And then on this other side, if I plug in a 9 right here, I'm okay with that too. That's going to be positive. So it looks like x equals 9 works. Now let's check negative 4. If I plug in a negative 4 here, if I plug in a negative 4 right there, well, that's going to be negative 4 minus 5, which is negative 9. Again, I can't take the log of a negative number, so this is going to be an extraneous solution. So your only answer is x equals 9. All right, on this next example, we have the natural log of 8x equals natural log 2 plus 5. Again, you still want to get your logs together, so let's go ahead and subtract that ln 2 to the other side. So we're going to have ln of 8x minus ln of 2 equals 5. We need to condense. So remember, when two logs are separated by a minus, they're going to condense to a division. So it's going to be the natural log of 8x divided by 2 equals 5. Now we can go ahead and simplify that and make that 4x. So this is the natural log of 4x equals 5. Since you have a single log, you want to exponentiate both sides. The base of a natural log is e, so we're going to do e to the ln 4x equals e to the 5th. So the e and the ln will cancel. So we will have 4x equals. Now go ahead and do e to the 5th on your calculator. The e to the x is right above the ln button, so you need to hit second ln, and then it'll put that e there, and then you just need to type in the 5 as the exponent. So e to the 5th power comes out to be 148.413. I'm going to leave that. There's a few more numbers, but I'm just going to leave it as 413. To solve for x, we need to divide both sides by 4. So just keep that answer in your calculator and now divide it by 4. And so x is going to equal 37.103. Now I would go ahead and check your answer, but when I look up here, if I plug in a 37 times 8, that's going to stay positive. And on the other side, there's not an x. So this checks, but again, you do need to check your answer. You just want to make sure you don't have a log of a negative number. All right, let's move on to some real world examples. So you deposit $250 into an account that pays 4.5% compounded quarterly. Determine how long it will take for the account to contain at least $500. So hopefully you remember from a previous video, we have this formula right here. A equals P times 1 plus R over N to the NT power. And hopefully you remember what all those variables stand for. We're going to deposit $250. Now this is going to be our P. That's going to be what we put in into an account that pays 4.5% interest. Well, remember you need to move that decimal over 2 places. So this is going to be our R. R is going to be equal to 0.045. It's compounded quarterly. So remember, this is your N, the number of times compounded per year. Well, if it's quarterly, then that means that it is being compounded 4 times per year. So N is 4. And then determine how long. So this is what we're trying to find. This is our t. So that's what we're trying to find, and how long will it take for the account to contain at least $500? So this is going to be our A. So let's go ahead and plug everything in. So we have 500 equals 250 times 1 plus 0.045 divided by 4, and then raised up to the nt, so that would be 4 times t. All right, so this is an exponential function that we're having to try and solve, so we need to get the base and the exponent by itself. So the first thing we're going to do is we're going to divide by 250. So that's going to equal 2. And then we will have, now let's go ahead and figure out what that 1 plus all of this is. So let's go ahead and plug that into our calculator. So that comes out to be 1.01125 to the 4t power. Okay, when we're trying to solve for an exponent, we need to log both sides. So we're going to do the log of the left using that same base, so 1.01125, and we're going to log base this side as well. Now I'm not going to write out all that the base right there because we know that this is going to cancel, and that's going to give us 4t. Okay, so go ahead and type that in on your calculator. Remember, you can do alpha window number 5, and then you just have to type in that 1.01125 for the base and 2 and hit enter. So this comes out to be 61.959. And to solve for t, we need to divide both sides by 4. So again, on the calculator, just hit divided by 4. You'll take your previous answer and divide by 4. So it looks like it's going to be about 15.5 years. So it's going to take approximately 15.5 years to double your money. All right, I know you're probably getting kind of antsy. This is the last problem, so let's get to it. It says the difference between the apparent magnitude, brightness, m, of a star and its absolute magnitude, capital M, is given by the formula lowercase m minus uppercase m equals 5 times log of d divided by 10, where d is the distance of the star from Earth measured in parsecs. The star Antares has an apparent magnitude. Okay, so it has an apparent magnitude, which the apparent magnitude looks like is lowercase m. So this 1.0 is going to be lowercase m. And it has an absolute magnitude, which an absolute magnitude is uppercase M. So this equals uppercase M. Find the distance, so this is what we're trying to find, which is our d. Okay, so let's go ahead and plug everything in. It says round answer to the nearest parsecs, which is going to be our nearest whole number. So lowercase m is going to be 1.0 minus uppercase m, which is a negative 5.3, and that equals 5 log of d divided by 10. Okay, so this is just solving a log equation. Let's go ahead and figure out what this is. This would change to a plus, so that would be 6.3 equals 5 log of d divided by 10. Okay, so we need to get that log by itself, so we need to divide both sides by 5. So if we do that on the calculator, we've got 6.3 divided by 5. That comes out to be 1.26. and that's equal to the log of d divided by 10. So now we need to exponentiate both sides. Well, the base of log is just base 10, so we're going to do 10 to the log on that side and then 10 to the 1.26. So if I do 10 to the 1.26 power on my calculator, it comes out to be 18.197 rounded. This is going to cancel with the log, and so it's just going to be d divided by 10. Now if I need to solve for d, I need to multiply both sides by 10 to get d by itself. So it looks like our d is going to be equal to 181.97. But because it says to round the answer to the nearest parsecs, it looks like it's going to be about 182 parsecs. All right, guys, I hope this video was helpful. Please make sure that you reach out to your teacher. This is our last week of learning, so reach out to your teacher if you need support.